Good morning, everyone, and welcome to today's workshop, Marine Data for Africa, for the Copernicus Marine Service. So my name is Gail Sterbeek, and I'm a training officer at Mercator Ocean International, and I'll be your host for today. So as you know, we will have a two-day workshop, and today we will have the introductory session where we'll tell you almost everything about the Copernicus Marine Service. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, please do not use the chat that you see on your right-hand side for your question. You can use it for small talk, to say hello to us or discuss with each other about your work. But if you have a more technical question or if you have any other type of question, you can use the Q&A section on the website. Okay, so you can see here the Q&A section on the website. So it's at the top bar of the page and you will find the Q&A button. And if you click, you will see the area dedicated to the Q&A where you can ask our speakers your question today. And next to it, you will also find the polls, so you can answer to it at any time of your convenience. Speaking of our speakers, we will have many presentations today. So I will start with a presentation of the Copernicus Marine Service, and then we will have Enrique Alvarez and Lilian Diarra from Mercator Ocean International. They will present the Ocean Prediction Decade Collaborative Center on the African Regional Team, and also the OPERA project. And then we will have a presentation of the visualization tool, MyOceanPro Viewer Pro by Leila Fab, also from Mercator Ocean. And then after a short break, we will have 3 presentations about specific application of these Copernicus marine products. So we will start with Protasius Mutjida from Kelp Blue in Namibia. Then we will have Valentina Santarsiero from Plantech Italia. And finally, we will have Karim Thiam from the Laboratory of Space Geophysical and Oceanographic Studies in France. So it promises to be a very interesting morning, and I hope you enjoy it. We will now start with the Copernicus Marine Service overview. So it's just a little overview to explain to you what the Copernicus Marine Service is about. So Copernicus is a program created by the European Union. So it's a European fully funded program dedicated to the observation of the Earth and to better understand different systems of the planet. So it includes 6 services. So the atmosphere, marine, land, climate change, emergency and security monitoring services. And well, obviously, the marine service is about the ocean and the seas. And it provides information and free of charge open source data products about all of these different systems of the Earth. So how do you access the service? Through its website. So it's free to access the website and to download any product. There you will find an extensive catalog of products. All of them are scientifically qualified and they are user-driven, so they are constantly upgraded and improved. And we also take into account the experiences of users of the service. So what kind of data the Copernicus Marine Service provide? It provides data on the blue, green, and white ocean. So the blue is all about the physical component of the ocean. So all that has to do with currents, temperature, waves, wind. The green ocean is the biogeochemical component of the ocean. So all of the phytoplankton, the nutrients, the chemical composition. And finally, the white ocean is so the ice, so the ice coverage, ice velocity, etc. So these are just a few examples, and also in terms of temporal and geographical coverage and the type of data the service provides, it is quite varied. So we have in situ data, satellite observations, which are used to validate model data. And then you can find data that are measured right now, what we call real-time data. We also have data from the past, so all the way back to 30 years, which are called multi-year data. And finally, we also provide forecast 10 days into the future. And in terms of geographical coverage, so we cover 5 areas or six regions, so the global region all around the globe. And we have also smaller area all around Europe. So also on the website, you will find a visualization tool that we call MyOceanPro. So there are 3 versions of it, and you can see you will see it's very interesting and it's a fun way to visualize the data. And we will have a presentation of MyOceanPro later in the day. So it's a really nice way to explore the data on the website. We also provide specific products like ocean monitoring indicator or data related to the climate. And in this case, the monitoring indicators are key variables that help us understand the state of the ocean. They are also accessible and free of charge, and they cover the past 30 years also, so long-term analysis. We also provide information, and one of the ways that we do that is by publishing a yearly report on the state of the ocean, so the Ocean State Report summary, and where we try to target more or less scientific communities, so more like policymakers or the media or just the general public. And yet, also to make sure that the information gets to everyone, we do that by creating 2 pages called the Ocean Explainers and the Ocean Climate Portal, where we explain some oceanographic concepts or current threats that the ocean is facing. And we try to explain it in a general way to everyone. And also the Ocean Climate Portal gives a perspective on the indicators, key variables of the climate and the ocean, but in a really accessible way for everyone. So as you can see, we try to reach a bit out of everyone, and the data we provide, it corresponds to different needs and or market, so blue market. It goes from science and innovation to policies, but also like to coastal services or different economy sectors. And also for today, you will hear about 3 practical applications that use the data from the Copernicus Marine Service. But on the website, you will find many more examples. And so we invite you to take a look on the use case pages. And even if you are a use case yourself and you use the Copernicus Marine data in your work, we also invite you to submit your work, because you can be on the page, and we also like to see what the data is used for, so don't hesitate. And yeah, beside all of this, we also try to make sure that the data is not only available, but also we can help people use it. So we try to make it as accessible as possible. So we organize workshops and webinars like this one, but we also have like hackathons or forums or other type of events to try to engage with this user. And you can also find the pages with all of the tutorials from the different workshops like this one. And yes, so that's all for me for today. So I hope you got a little glimpse of what the service is about. And I invite my 2 first speakers, so Enrique and Liliane, to present you with their project. Liliane and Enrique, so whenever you want, you can start your presentation.
Okay, Enrique is supposed to start. Just hold on, please. Well, maybe I should stop my slides while we're waiting for him.
Yeah, we can go to your slides first. Yeah.
Okay, do I have control or?
I don't think so yet. So
Okay.
yes, we will go to the No, you do, so you can go to the Opera project presentation.
Okay, so good morning, good afternoon, everyone. So my name is Lilian Diarra, and I'm managing a project called Opera at Mercator Ocean International. So I'll be presenting this project, but this project is actually in the framework of the Ocean Prediction Decade Collaborative Center, which my colleague Enrique Alvarez will present when he joins us. So I'll just tell you a bit about this project because it's targeting really the African marine data community. So let me just, I can't really move my slides. But anyway, I can just speak. It's okay. So this project is a 4-year project that's funded by the European Union. Thank you. Thank you. So it's a 4-year project funded by the European Union. OPERA stands for Ocean Prediction Enhancement in Regions of Africa. So it's really to improve the management, the sustainable management of marine resources and human welfare in sub-Saharan Africa by promoting ocean forecasting and its applications. So how are we going to do this? We're going to establish different consortia of African partners. 2 will be specialized in developing thematic applications running on ocean forecasting products, and 1 will be developing ocean forecasting systems, both regional and coastal. So we're going to have this network of digital ocean centers in Africa linked to global and European networks via the Ocean Prediction Decade Collaborative Center. So this project is very new. It started in January 2025. This first year will be really establishing the consortia through open and competitive calls and doing all the groundwork of mapping ocean forecasting activities in Africa and setting up the project. So by 2026, January, consortia will be all established and the project will be in full implementation. So as I said, it's funded by Europe through the Director General, the Ministry of International Partnerships, who is eligible. So this is really limited to sub-Saharan institutions, and this is something that's decided by the European Commission. So North Africa is not included, and it will be implemented by Mercator Ocean International through its role in the Ocean Prediction Decade Collaborative Center, leveraging its expertise in Copernicus Marine and the development of the European Digital Twin Ocean. Next slide, please. Oh, sorry, I can do it. So it has five main objectives. So it's really to strengthen cooperation and the community in Africa around ocean forecasting. So this is contributing to the Copernicus Marine community. The second is really to develop capacities to develop, use, and access ocean resources. This is ocean forecasting models and data. And this I want to emphasize because we will be developing massive online open courses over the course of the project and really focusing on how to build, implement, and also evaluate an ocean forecasting system. So this is going to be really interesting for the African community. And the first one is set to be launched at the end of this year. There will also be some summer schools, but this will be really linked to the different participants in the project. The third objective is really to co-design and develop these ocean services and applications integrating ocean forecasting products to be operated by these digital centers, so the different consortia that we'll set up in Africa. And the fourth objective is to really co-design and develop ocean forecasting systems for essential ocean variables. So as I mentioned, we'll be designing and developing, co-developing at least 1 regional ocean forecasting system and up to 3 coastal ocean forecasting services in the region. And the last one is really this notion of sustainability, science to policy, user uptake, with a focus on the development of a notion of a marine knowledge hub that will integrate all the different results, models, and services developed within this project. And just to conclude, so this is Africa's really in the core of the Ocean Prediction Decade Collaborative Center activities, as Enrique will speak about in a second. We're really trying to build an active community around ocean prediction in Africa, and really starting with an African regional team that we have established in the Decade Collaborative Center. We're going to develop new tools to promote ocean forecasting. So as I mentioned, we're going to develop new applications integrating ocean forecasting data, different systems, coastal and regional, and also software. And this is really key resources that will be available for the African community. And as I said, we'll be doing massive capacity development activities, really targeting Africa. And we really invite you all to join this community and stay informed on all the different opportunities. And there's a link shared that will be shared in the chat. So I think I'll stop here, and I hope Enrique is available.
Yeah, I'm available. Sorry for being late. I misunderstood the date of the meeting. I thought it was on Wednesday. On my agenda, it was on Wednesday. So I apologize for that. So I'll jump into this presentation by explaining the main task of the Ocean Prediction Decade Collaborative Center. And basically what we are trying to achieve is promoting ocean forecasting worldwide. On the left, you have the systems that we have today. What we have is good systems. We are proud of these systems, but we have to admit that those are difficult to implement and difficult to operate. And we don't have a community around these systems implemented. Those systems are also technically somehow disconnected. So we want to change to a different scenario where we will have all these systems connected through a community and also technically connected. So this is a big transformation that we are going to work for. And we're going to do this in the framework of the decade with the community that we are building. And it's important, as Lilian was mentioning before, that you join this community to do not miss the actions that we are taking here. So next slide. Okay. Sorry.
You can use the keyboard arrow, it will be easier.
Thank you. So we are doing that through two pillars. The first pillar is this community that we are building. The main focus point for this community is the web page, where we have the atlas, we have the forum, and we have other resources. And the second pillar is the technical one, where we are developing all the technical assets that are helping us to move forward on this task. If we focus on the first pillar, on the community building, it's important to mention that we are doing that through regional teams. The regional teams are, let's say, our ambassadors around the globe to promote ocean forecasting and its applications. And when you look on the institutions that are ruling these regional teams and are participating on the steering teams of these regional teams, you have this fantastic map of institutions worldwide working for this common goal of promoting ocean forecasting. Very relevant is the atlas in the web page. This atlas, as you can see, has 4 sections. One is for the people that is part of our community, other one for the institutions, the forecasting system, which is in fact what you are seeing here. This is the map of the ocean forecasting systems that are available around the globe. This is already quite comprehensive, but this is still in the making. And finally, we have the use cases or downstream application, however you want to call this. So it's this atlas is a very important focal point to demonstrate who is who, to show who is who in our system. You are welcome to be part of this community. We invite you to join the DCC and to join the atlas, so you are visible there. I want also to talking about Africa. That was a work that we did to prepare the OPERA project that Lilian was explaining previously to you. And what we did was a survey to gather insights from experts on the current state, the challenges, and the future prospects of ocean forecasting services in Africa. So we opened this through the Africa task force of dedicated to everybody in Africa. We got 134 replies talking about present-day situation, future needs, and other. You can download the results of this survey from the Ocean Prediction DCC webpage. And amongst other results, you can see here the cross-cutting needs, the additional needs related to ocean forecasting. And it is very relevant for the meeting today that capacity development is for African partners, for the members of the Ocean Prediction DCC community at Africa, the most urgent and relevant task. You can see here the blue bars correspond to the global, and the other bars correspond to the different regions in Africa. So in all the regions in Africa and in the global, capacity development is the outstanding need that people from Africa is asking for, followed by dedicated funding for this task. So as a summary of the African survey, the response outlines a very clear way forward of what people in Africa is demanding for the future. First of all, community building is an important fact. People related with these tasks are not yet properly organized through a community in Africa, and we need to promote further sharing of data and knowledge among African experts. Capacity development, as I was mentioning, is a big need. And we need to prepare a new generation of scientists and technicians to provide African solutions from African problems. It is clear the demand of African solutions for African problems. New forecasting system is an outstanding demand. We need better system. We need higher resolution in the coastal seas of Africa. And we need new or improved application to exploit the result of these systems. Finally, it's also very relevant the need of user uptake and societal engagement. The concept of leaving no one behind is very frequent on the replies, considering indigenous knowledge and involving all sectors with a special focus on women and young people. So this is the overarching. Okay, now my screen go to black. I don't know if you can see.
We can still see the slides.
It's strange because my screen went completely to black. So I don't have an idea why. Nevertheless, last slide, can you see the changing slide now?
Yeah.
Okay, so last slide is just an example of the kind of technical assets we are developing for Africa and for other regions. In particular, this is the Ocean Prediction DCC architecture, where this is a document that we created teaching how to build an ocean forecasting system from scratch, teaching all the wiring that is needed to build an ocean forecasting system. And like this, there are other technical documents that we are building and that will be of paramount interest for Africa community and that we will exploit in the OPERA project. So this is it from my side. Sorry again for the very my late appearance due to a mistake on my agenda and the difficulties that I have had with the presentation now. So thank you very much.
Thanks a lot, Enrique, for your presentation, and Lilian also. So we will go to the Q&A, where we have a few questions for you. Okay, so just waiting for the question to appear on the screen, and then we can start. So the first question, how does the ocean prediction community support scientists and researchers in countries outside of Africa?
So I can jump into this one. As you can see, we are building this community, which is by itself a point of support for everybody. So people in the forum that we have built can ask questions and can get answers about their difficulties related with ocean prediction. And furthermore, all the technical assets that we are building are going to be fundamental for the developing of ocean forecasting systems in the future. This links also together with the capacity development that we are building now for Africa, but will be exploited in the future for the rest of the areas of the world. So in this sense, I want to highlight that Africa is pioneering our efforts thanks to the active community in Africa and thanks to the OPERA project. So in fact, what we are going to develop for Africa is going to be later used for other parts of the world.
Thanks a lot for the explanation. So we will go to the next question. What can we do to be part of this project? I didn't saw Cabo Verde Islands, West Africa. We are interested.
So I think that is very relevant that you identify yourself in our community. Please go to our webpage, register yourself, register your institution. If you are running an operational forecasting system, don't forget. If you're running an application, don't forget to include that on the atlas. So being part of this community is certainly the first step towards being part of these projects.
Thanks a lot. And a question about partnership. Will you be interested in partnering with institutions, companies, or individuals?
A big yes to all of them. We are interested in, if you go to the atlas, you will see that we have 4 sections. One is on institutions, the other one is in individuals, and the following sections are for the technical systems, for the forecasting systems and the downstream services. So the answer is a big yes for all of these institution, companies, and individuals.
Yeah, can I just jump in? For the OPERA project, if you're interested, there will be an information day sometime in May, and this will be announced on Copernicus Marine website and also on the Ocean Prediction DCC website. But the partners here, we're looking for a more at institutional level. Yeah.
Okay, thanks a lot for the specification. So we have 2 questions asking if their different countries are part of the project. So the first one being, is Mauritania part of the project? And also the same question for Tunisia, if they are already part of the project.
So I would like to highlight here the 2 different things that we have been talking. I have been talking about the DCC, and Lilian have been talking about the OPERA project. The participation on the DCC is of paramount importance to build our community, and it will be linked also with the OPERA activities. So everybody in Africa is welcome to participate in this community that we are building on the DCC. So once again, you have to go to the webpage, register yourself, be part of the community, make sure that your institution is there. With respect to the OPERA project, it will be organized through a competitive bidding. This is why we are going to have this session that Lilian was explaining. And for the OPERA project in particular, due to the origin of the sourcing was INPA money for the sub-Saharan Africa. It's impossible for those countries in the Mediterranean, in particularly in Tunisia, to be part of the OPERA project. But this is not a decision, let's say, that we have taken. This is part of the opportunity that we are taking advantage with these funds that were only focused on sub-Saharan Africa. It's our hope that we succeed with this project, and it's our hope that in the future there will be similar calls for other parts of the world. But this is just speculative. We need really first to succeed with OPERA project.
Okay, thanks a lot. So I will mark this one. A question more about the data. Will you need partners to provide in situ data from ground truthings like chlorophyll A?
You want to jump on that one, Lilian, or shall I go?
Go for it.
So ground truth is absolutely fundamental for us, because we can do modeling without ground truth. This is the very basic fact. So to be in contact with the data providers is fundamental for us. But it is also true that the OPERA project is focused mainly on the ocean forecasting systems. And we are going to develop new ocean forecasting systems and applications. So as a grant provider, certainly you're very welcome on the community organized by the DCC, but maybe the OPERA project is not going to be focused. We don't have, for example, budget on the OPERA project for new instrumentation.
Okay, thanks a lot. I wasn't sure if Lilian wanted to add anything.
No.
This question, how is this project important to students, and is it just as important to countries like Zambia that are not anywhere near any ocean?
Lilian, that's for you.
So for students, as I said, there'll be a lot of capacity development activities, starting this year with a massive online open course on the principles of developing an ocean forecasting system. So this is, I think these will be courses over the course of the 4 years with different levels of let's just say, advance. So this is really good. I think it'll be a really, really important opportunity for students. There will also be so with regards to Zambia, I mean, sometimes what happens on the coast will affect what happens inland. For example, cyclones. If there's cyclones and storm surges, this will also result in very heavy precipitation in countries like, when you have cyclones hitting the coast of Mozambique, this impacts countries like Zambia and Zimbabwe. So I think early warning systems, even for coastal countries, will be quite important for inland countries. I don't know if you want to add anything, Enrique.
No, that's perfect.
Thanks a lot. So a few other questions. Are there opportunities for professionals with my skill set to contribute to your work, either through collaborations or career opportunities? So the skill set is not defined, but
yeah, that's a difficult one because we don't know your skill set. But I think that once again, the important fact is that we are building this community, and this is going to be a focal point. First of all, to make yourself visible, to show your skills, and to link with career opportunities in the future. So this is part of the magic of the community we are trying to build here.
Thanks a lot. So we have almost the same question about how can professionals with both marine engineering and data analytics expertise can contribute to solving this challenge. Now we have a background.
I think that, as you say, this is the same question, and we can say that this is it. Same reply.
Yeah, exactly. Okay. Another question. How can OPERA leverage Somalia's long coastline and use full energy for coastal innovation?
Go for it, Lilian.
So as I said, part of the OPERA project, we're really going to try and build this African community, ocean forecasting community, and we're leveraging the Ocean Prediction Decade Collaborative Center. So I mean, we're going to have a number of community building actions, stakeholder engagement actions, and this is just really, we're trying to reach out to all these to this energetic youth in Somalia and in other countries to be on board. But of course, it also takes, on your side, you'd have to log in and register on the Ocean Prediction DCC website to be kept informed on all the different opportunities and activities. Because I mean, there's so much we can do on our part, but it's a two-way relationship. Thank you.
Thanks a lot. Okay. Does this project relate to some technique of ocean inspection or something like that? Open question. It's not made available data and to the community.
So I think I don't really get the meaning of the words ocean inspection, but OPERA project is related to ocean forecasting and applications, and the development of application, the exploitation of the ocean forecasting for practical uses in Africa. So this is what we are trying to do with OPERA, and certainly this is on the framework of the larger umbrella of the DCC.
Thanks. Thanks. So we have time for a few more questions. Many software tools are used in African institutions for environment data, Puma, UMEDSAT, etc. Do you plan to use or partner with them?
So we are open, as I don't know if you got that clear, but in OPERA we are going to go through a competitive process where we are going to develop the most needed and better presented ideas for the development of applications in Africa. Those could be development of applications already existing. So we are not close. Certainly, we don't want to start from scratch. We know there are applications going on in Africa. So one of the possibilities could be to invest on the improvement of the existing applications. Always focus on ocean forecasting, because this is what OPERA is about.
Yep. Just to add on, we are in contact with EUMEDSAT, and we're aware of what they've put in place, but they're mostly concentrated on climate and weather services, and we're focusing on ocean forecasting. So there's a bit of a difference, but we are aware of different communities to make sure there's no duplication, and also that we can build on what's already existing.
Okay, thanks a lot for the explanation, and we have time for one or two more questions. This one, how could journalists keen to have access to marine data to produce in-depth journalism fit in the two projects?
Lilian, you want to jump into that one?
Thanks, Enrique. I guess they would have to also be part of the community, so they can, keep abreast of what's happening, and they can also feel free to contact us. We're going to have regular communications. Right now, that we're going to have a first communication this week, hopefully, and this is just keeping track of what's happening on social media, websites, and just contacting us directly. But we will also have these annual workshops, and that will also be an opportunity to engage with journalists, and this will be very important to get political buy-in and all that. Yeah.
Thanks a lot. So yeah, all of the links have been provided in the chat for the participants. So for the people who want to have more information, you can always have a look at that. So I take this more open question. I don't know if you will have the answer to that.
I can jump on that one. So as I was briefly mentioning, the Ocean Prediction DCC has these two pillars. One is the community building, and the other is the technical side. And on the technical side, we are trying to approach the actual status of things such as artificial intelligence and other advanced techniques. In fact, we are working, and I hope it will be published in a few months, a special issue on ocean forecasting, and this team working on the technical side have compiled 27 papers that will be published in a special issue, and most of them are related with those advanced science techniques such as artificial intelligence and others. This is what we have done up to now and what will be published soon. And what we want to start doing now is to start analyzing how these techniques can really have an impact in the future, and how can these techniques fill the existing gaps. For example, artificial intelligence is going to be very important related to ocean forecasting, because it will facilitate a lot the implementation of forecasting systems with lower need of big computers, of supercomputing machines. It will classical ocean forecasting will not disappear, that is for sure, but probably in the future it will be used to train artificial intelligence, and the result of that is that we will need much less computer power to do our forecast, and probably we are going to do better forecast with lower computer demands. So this is the view that the community has now. Mercator Ocean is working actively in that. And Ocean Prediction DCC is trying to grasp all these facts, include this in the publications that we are making, and doing analysis of what is needed for the future and how the future will shape. So we are a little bit in the DCC having the role of the navigator, setting the course for the future, not maybe doing all the things by ourselves, but keeping an eye on the status, linking the community with the technical part, and moving forward with all that.
Thanks a lot for the good explanation. So we will have to stop there for the question. But yeah, for all of the unanswered questions, we will put them together in a post-event report, and each of the speakers will provide the answer. And yeah, it will be made available, so no worries. Thanks again, Enrique and Lilian, for your nice presentation and your participation. And have a nice day, and we will go to the next presentation of MyOceanPro.
Thank you very much.
Thank
I'm
you.
sorry for my problem with the agenda.
No worries.
And arriving late. I'm really sorry about that. Thank you.
No worries. Have a nice day.
Have a nice day. Bye.
And yes, so now we will go to the MyOcean Viewer Pro demonstration. And yeah, Leila, whenever you want, you can start sharing your screen and do your presentation. Welcome.
Okay. Hello, everyone. Okay. So today I'm going to introduce you to the MyOcean Viewer. So it is accessible from the Copernicus Marine Service homepage. You just have to click on Ocean Visualization. So we offer 3 types of visualization tools: MyOcean Learn for the beginners, MyOcean Lite for intermediate users, and MyOcean Pro for experts. And today we are going to talk about the latter, so we are going to explore it. So now we are on a map on which 2 default layers are displayed: the seawater velocity and the mass concentration of chlorophyll A in the seawater. On the map, you can move around. You can zoom in and zoom out by scrolling with your mouse, and you can change the projection when you use these 2 buttons. So you can choose the North Pole projection and the South Pole projection. With the bar at the bottom, you can change the date that is displayed. So right now we are seeing the data for the 4th of March, 2025. But if I click here, I'm changing the date. You see that the map was updated. And now I'm seeing the data for the 3rd of September, 2024. If you want to select a date more precisely, you just have to zoom in on the bar by scrolling with your mouse, and then you can select a date. And you can also use your keyboard arrows to change which day you want to display the data. And then you can reset the zoom. With the bar on the right, it's the same thing, but for the depths. So right now we are seeing the data at the sea surface level, but if I click here, you can see that the depth level has changed and the map was updated. And here we can see the bathymetry. Same thing as the other bar, you can zoom in to select the depth level more precisely, and you can use your keyboard arrows to change the level. Okay, so the first thing we are going to do is choosing our own layer to display on the map. And to do that, you just have to click on Add Layer. So it opens the Copernicus Marine Data Store, in which there are 303 products. They are sorted in many categories. So the popular products, the product recently viewed, the new products that were added in the data store, and so many other categories. We are going to filter which product we want. So there are 2 ways to do that. First, you can type in a keyword. For example, if I type in temperature, I get 138 products that include temperature data. The other way to filter your search is by selecting the different parameters on the left. So you can choose the time range, the universe, the variables you want to observe, the area of interest, the temporal resolution, the source of the data, and so on. For this presentation, I'm going to select the global ocean as the area of interest so that Africa is included. And for the variable of interest, I'm going to select the temperature. And now we are down to 29 products. Under each product, you have some information. So first you have the name of the product. Then you have the product ID, and you can copy it by clicking on it. You have the indication to know where the data come from, if they come from a numerical model or from satellite observations or in situ observations. You have the area covered by the product, so global, the spatial resolution, the temporal resolution, and the main variables present in the product. You have the possibility to add a product to your favorites by clicking on the star, and then you can retrieve the products in the favorites tab. Okay, so I'm going to click on the product's image, and it opens the description page of the product. And here you have a short overview that gives you the main information, general information about the product. You have the DOI, you have some use cases, and at the bottom you have the product's metadata. Under the description tab, you have the notifications. So here you have the latest news about the product. You have some general information, but you also have incident, improvements, and maintenance notifications. And if you want to learn more about a notification, you just have to click on it and read the details. Under the notification tabs, you have data access. So here you will find the list of all the data sets available in the product. And here you have the three methods available, the three services that you can use to download data from the product. So the subset service, the file service, and the map service. If you don't know about these services, you just have to click on these icons to read articles from our help center that explain how to use these services and how they work. And then you have contact. So if you have a question about the product, you can just click here and you will be talking with the user support. Before contacting us, if you're looking for an information about the product, I recommend reading the documentation. So there is the user manual, which is a technical document, or the quality information document, which is a scientific document. We also have a synthesis quality overview and a product quality dashboard. So check these documents before you will find what you're looking for. And if you want to see the evolution of the product, you can check the roadmap here. So I'm going to use these products for the presentation. I click on Add to Map. So first you can see that I have all the layers that are relevant to the temperature because this is the filter I've selected. But if you want to see the other layers, you click on All Layer and they are here. Okay, I'm going to add this layer because it is the seawater potential temperature and it is daily data. So this is what I want. I click on Add to Map. You can see that it was added on the map. All right, so we are going to focus on the functionalities on the left. So the first thing I want to show you is that you can hide or show a layer by clicking on the eye icon. And you can also change the layer's priority. So to do that, you click on a layer, you hold it, and you put it above the other, just like that. And you can delete a layer by clicking on the cross here. For each layer, you have several functionalities. So with this icon here, you can retrieve the information we saw before. With this button, you can select other layers from the same product. So if I want, I can choose the seawater potential temperature in a 6-hourly resolution. And with this button, with this gear icon, you can customize your layer. So you can change its opacity, you can change its color, You can invert the color map with this button. With this button, you can contrast your map. So you see here you have a threshold. You just have to select which level you want, depending on what contrast you want on your map. You can change the minimum and maximum values on your map. So for example, if I say that I want the maximum value to be 15 instead of 30, and I click on enter, you can see that the scale has changed, and so has the map. Yes, and with this button, you can mask the outliers. So if I click, you can see that all the values above 15 were removed from the map. All right, and with the auto button, you can automatically increase the contrast. So I'm going to show you how it works. So it analyzes the data that are currently visualized on the screen, and it selects the suitable minimum and maximum values, just like that. With some layers, there are more options, and this is the case for the seawater velocity. So there is the possibility to, wait. Okay, so there is the possibility to enable the log scale with this button, like this. And in the gear icon, there is the style option. So right now, the solid style is displayed. But if I want, I can display the solid and the particles. So now you see, I'm going to zoom in. We can see movements on our map. This is the direction of the seawater. If you don't want movements on your map, you can select vectors instead, and you can see that there are arrows that are indicating the direction of the current. You can also remove the solid style, and then you can have the seawater potential temperature layer, and above that you have the particles that are indicating the direction of the current. All right, now we are going to see the functions on the right. So with MyOcean Viewer, you can create objects. So you can create points, you can create lines, and you can create areas like this. You can see that for each object, graphics were created. So you can maximize them if you want to see them better. And then you can adjust the axis for each graphic. So you can change the start date or the end date. And then you can export the graphics to 3 formats: the NetCDF format, the CSV, and the SVG format. If you want, you can add more graphics like that, and you can delete it with remove graph. With the objects, you have the possibility to group them so that you can compare them. I'm going to show you. You just have to click on a graphic and put it above another one. And then you have A and B, so the 2 objects, and you can compare them on the graphics. You can see here. To ungroup them, you just have to click here. Okay. Yes, and to close an object, you just have to click on the cross of the graphic. Okay. Under the 3 objects, you have the import button. So with this button, you can import geometries. So geometries can be imported in the well-known text format, in the JSON format, and in the shapefile format. There are also presets that are available. So these are geometries that were also already configured for the viewer. So for example, if I click here and then import, I have an area that was an object that was already created. Then you can add a graph and work with your geometry. In the import button, you also have the recent tab so that you can retrieve your work even if you close the window. So you can see all the geometries I've already imported in my Ocean Viewer. Okay. Under the import button, you have the settings. So in the settings, you can log in or log out from your account. You can change the way you want to display the map. You can show toponyms to have the name of the marine areas. You can change the projection. You can show additional graphic statistics on the graphics. You can change the object units. So there are many possibilities that I will let you explore on your own. Once you're done working, you may want to download the data you've worked with. So to do that, you just have to click on this download icon. So you have to enter the geographic area for the data you want to download. So you can do that manually, but you can also use the Define on Map button. So I'm going to show you how it works. The first thing you can do is draw a shape, and you see that the geographical coordinates were automatically written here. Or the other way you can use the Define on Map button is by selecting an object you've created just before, like this, and you see that the geographical coordinates were entered. When you have a complex shape for your object, for example, a triangle is a complex shape, you need to note that this is not the data inside of the triangle that is going to be downloaded, but rather the data inside of this square. Okay. Then for the date range, it's the same thing. You either enter the dates manually, or you can click on As in Map. So I'm going to change the end date. I change the date, and then I click on As in Map, and you can see that the end date was changed. Same thing for the depths. I'm going to change the level, click on As in Map, and it was changed here. So once you're done writing the parameters for the data you want to download, you just have to click on this download button. Sometimes you will see that if the data is too big, you will get this message: too large subset, try reducing it or use other download services. So first, yes, you can reduce your request for the data, but if you don't want to, you can use the browse files. So with the browse files, you can download data as originally delivered by the producers. So you just have to select a year, a month, and then you download a day of data, because I'm using a daily data set. You need to know that one file will contain the whole geographic area, all the variables of the data sets, and all the depth level for one day. The other way to download your data, if it is too big, is to click on the Automate button. And then you just have to copy the request for the command line interface like this, or the Python API, and use it with the Copernicus Marine Toolbox. If you don't know about the toolbox, we have articles in our help center that you can read, but I'm also presenting this tool on Wednesday. So yeah. You can also share your work by clicking on this button. So first you can create a link that will include all the layers, all the objects, all the graphics you've created. You just have to copy it like this. You can create an image. You can add or remove the legends and the time and date caption. You can download the image or share it. You can generate a video. So you choose the start date, the end date, the duration of the video. It can be in the MP4 format, or it can be a GIF. And then you just have to click here. And finally, you can create a named link so that you can include the map and its functionalities in a website. On the viewer, there are many shortcuts available. So you can discover them here. So there are many shortcuts. I'm not going to show you all of them, but for example, with the Z letter, you can remove all the tabs so that you can see your screen more clearly. And if you have a question, you just have to click here. So this open this window. First, I recommend you to click on Help, and then type what you want answers for. For example, if I type in MyOceanPro, I get many articles about it. If I click on Introduction to the MyOceanPro Viewer, I have an article that gives you all the information I told you during this presentation. But if you don't find your answers in our articles, you just have to click on Messages, then ask a question. So first you will be talking with Blue, our AI chatbot, but if its answers are not satisfying, or if you really need to talk with a human, you will have the option to click on Talk to a Person, and then you will be discussing with a member of the user support team. All right, I'm done with the presentation now. Thank you for your attention, and don't hesitate if you have a question.
Thanks a lot, Leila, for your presentation. So, really nice demonstration as always. We have a few questions for you.
Yes.
So the first question being, can students use your online simulator for personal activities?
Yes, of course you can. It's free to use, so use it as you wish.
Is it? Oh, it was a little slow. What tools and methods are used to advance and carry out ocean forecasting activities except MyOcean software?
What tools and methods? If it is to download forecasting data, we have many tools. So we have the file browser that I showed, the toolbox that I will present on Wednesday. But if you want to visualize the data, forecast data, MyOcean Viewer is the only tool you can use.
Yeah, maybe like we use numerical models also to satellites data to validate models data. I'm not sure that was the question, but yeah.
Yes, I'm not sure about the question either. I'm not sure, but if I didn't answer your question correctly, don't hesitate to chat with us.
So about the catalog, do you have data of marine currents in the Mediterranean, especially in the Algeria region?
Yes, we do. I think you can check in the data store. And if you don't find the data, come talk to us. But I really think that we have this kind of data.
Yeah, in the Mediterranean Sea, I
Yes.
think. Yeah. I
Yes,
think, yeah.
we have products, especially for the Mediterranean Sea.
A more open question. Can you guide us about the best software to use and how to learn fast?
Okay.
Yeah.
I think like what?
I would say like it's a question about like Python or RStudio or something like that.
Ah, okay. So the best software to use, I don't know what you want to do, so it all depends on what you're working on. But we have articles that will help you on how to use Python, R, Julia, to download the data, visualize them, so you can check our help center.
It's a lot. Okay. I am doing remote sensing for water quality monitoring. Do you have any online in situ data for model validation purposes?
Yes, we have in situ data. you can check in our data store. On the left, you have the option to you select in situ, and you will have in situ products only.
Exactly. Thanks a lot. So this question, is it possible to retrieve the numerical data? So,
numerical?
I would say just to download the data. That's how I understand
Yes.
the question.
Yes, of course. I showed you how to download data from the MyOcean Viewer, but you can use the file browser and the toolbox.
Thanks a lot. And yeah, for the toolbox, so you can come
Wednesday.
on to have the
Yes.
demonstration by Leila also.
I will show you how to download data with it.
How do you know what the time units are when you download the data?
So if you download the data from the MyOcean Viewer, on the graphics, you will see the time units. How do you know what the time units are? It just depends on the data set you are selecting. So based on the data sets, you will know what's the time units.
Thanks a lot. Yeah, so all of the information are written on the project. Does the evolution of the data layer have to do with correction? What kind of correction? And when do these corrections occur?
So the evolution of a layer of a product depends on it's for correction sometimes, but it can be for improvement. Sometimes the spatial resolution is improved, and some improvements can be done because some users requested it. So these corrections occur. It depends. It's not always regular, but there are updates several times a year for the products. You
Thanks a
can
lot.
check how is it called? The product roadmap. If you check the product roadmap, you can see which products were improved, what were the changes. So yes.
Thanks a lot. So yeah, we have time for like one or two more questions. So great use of the API. Is it free? And if it's the case, how long can we use it in our project?
It is free, and you can use it whenever you want, for how long you want.
Exactly. Thanks. So what is the best resolution I can get from my Ocean Data Viewer?
Oh, I don't know. I would have to check.
Yeah, I'm not sure. I would say the smallest resolution is like 1% of a degree, something like that.
Yes, I think, but I'm not sure. But you can check on the viewer or ask us through our chat. But I think Gael is right.
And okay, so one last question for your presentation. Are there available variables only the one in the left windows under main variables, or are there some more that you can search for in the free text search engine?
Yes, there are more variables, but the variables on the left were the most used variables, but there are many more variables. If you explore the products and the data sets, you will see that.
Okay, good to know. Thanks again, Leila, for the presentation, demonstration, and the Q&A. So as usual, I will put on the side unanswered question. Thanks again.
Thank you.
Yes, so we will take a 5-minute break, and then we will come back for the use cases from the external speakers. And yeah, feel free to chat with each other in the chat room, grab a coffee, and take a look at the poll. See you in 5. Welcome back, everyone. So, welcome back. So, I hope you had the time to take a short break. We will continue today's workshop, and we will start with the presentation of Protasius. So, welcome, and whenever you want, you can start the presentation.
Okay, we can start.
Yes, it's okay. We can see the slides, so you can go.
Thank you so much. Good afternoon, I think, to everyone. My name is Protasius Mutjida from Namibia. I work as a chemist at Blue, mainly focusing on water quality as well as hydrographic. I'm going to share a study that we concluded on geochemical baseline study of a giant kelp at the Blue farm. This was conducted with different institutions. So I'm just including for my slide. So I'm just gonna give you through an overview of everything. So let's start with quickly the introduction. There is a big issue in the world today, and that's the issue of climate change, where the Earth's atmosphere have contributed to global climate change, which affects a wide range of communities, individuals, and also ecosystem. Because of this, different world leaders are calling for significant changes to the emission of greenhouse gases, especially CO2. We have every year different climate change summit and meetings to address this. So there has been various strategies that has been suggested globally and also by different countries to mitigate CO2. So one of them is basically that the ocean is the biggest reservoir of carbon. So it takes out carbon from the atmosphere, absorbing about 2/3 of that by different anthropogenic activities. So within the ocean, we see that the CO2 then interacts with the different geochemical parameters, and looking at these geochemical parameters, both in situ as well as using satellite, as well as using the different numerical model, can assist us to understand the different work. But I mentioned earlier that there has been suggestion on how we can combat this. One of them is through different reforestation activities, grassland, rainforest. But specifically, my topic today is on giant kelp. We are situated in Namibia, as I mentioned earlier, at the coast of Namibia, south of Namibia, called Lutherets, where we are growing giant kelp, Microcystis prefera, at a large scale with the aim of basically harnessing or capturing carbon as well as boosting biodiversity. So this research then looked at, before we grow this seaweed, we needed to find out what is there within the ocean, what are the geochemical parameters. But what we saw is that there were less information given or research has been done or water quality samples collected within that area of Lutherets. As much as Lutherets is an upwelling cell, an active cell that is centered between the cold Benguela upwelling cell in the northern part and the southern part. For us to quantify the scale forest, we needed to develop a baseline study that shows this is a geochemical parameters before the farm was installed and after that. So because of that challenge, we then looked at an objective basically of the study, and that is to develop this comprehensive geochemical baseline of the giant kelp at the kelp blue farm to be able to then in the future to assess its potential to sequester carbon. So we did this by monitoring the changes in the ocean geochemistry around the kelp forest. We compared the geochemical parameters at this farm that is gonna grow kelp and away from the farms, as well as then we created a baseline that assesses the potential this kelp forest can do. So how did we do this? We did both in situ analysis as well as using Copernicus marine services basically to ground truth that. So we looked at different sites. From the city of Lutherets, we looked further north at Bodby, Pilot, and then at Dunfudge Rock, and then within the kelp forest farm itself. So we use different instrumentation and different parameters basically to collect this data in situ, sample bottles, sediment grab. So we didn't only collect water samples, we also collected sediment to look at pH, temperature, nutrients, oxygen conductivity, and the list goes on. So once we have collected, we have our instruments in place. What we did then is do the frequency and then also the profile of how we collect our samples. So we collected water at the surface and 15-meter and 30-meter, mainly because the site at the time that where the kelp forest was growing was not more than 60-meter depth. So we took this profile where we then collected water with sondes. We did titrymetric analysis. We also deployed sensors as the different site. When it comes to sediment, we used different research vessels and our in-house vessel to collect sediments using CTD as well as multi-Cora that then collected this sediment that was analyzed for loss on ignition, as well as looking at the elemental analysis of this sediment. So once we did that, then we begin to interpret this data. We looked at Copernicus Marine Services. We looked at all of the data that has been collected within that area and compare and see what are the spatial difference with what we did in situ. Then the data then we interpreted and visualized with different softwares, Studio, Cepha, Ocean Data View, as well as Quantum GIS. So I'm going to share with you some of the findings. I'm sharing this because the paper has been released. We're waiting for peer review report, but I think it's something interesting to share. So we looked at all of these geochemical parameters, conductivity, pH. We saw that the pH ranges between 7.8 to about 8.02 or 0.03 rather. And as well as the dissolved oxygen was in the range of 4 to about 7 at some places. And then we, using Copernicus as well as our in situ data, we then begin to generate this data using Ocean Data View to just show the heat map of which areas have highest amount of dissolved oxygen as well as pH. So as you can see from there, that most average dissolved oxygen was in the range of 6.5 to 4.5. Similar to temperature, because it's kelp that we're growing, it has to grow in nutrient-rich water as well as cold temperature. So it's in the range of 17 to, from 9 to 17 there. And then we also looked at the remineralization within the water column as well. And then we looked at the nutrients cycling, which is very important because if we are growing this giant kelp, we want to see how is it in its interaction with the different phytoplankton community within the area. So we collected water sample using photometry, nitrite, phosphate, nitrate, silicates, as well as ammonium rather. And then we also saw that the results, especially when it comes to this actually sediment, is that we had a high amount of iron, especially close to the port of Ludwig, while further from the port of Ludwig, there was less amount of iron, as well as other metals as well. And then we did sediment collection, as I mentioned. So what we did is we looked at the carbon content moisture in the sediment. So both within the Ludwig area, but also we had an opportunity to collect samples further north of Namibia, almost close to Angola, 20-degree transect. And we saw that in the range of 22 to 24-degree line, it's where there was a high amount of carbon content. And this was very important in research because it then supplemented and also supported the claims done by Mohala, where they recognized that the Walvis Bay Ridge has a high amount of carbon content accumulation, which is called a depot center, that most of the organic rich sediments are found within the Walvis Bay Ridge. So this is interesting and also very satisfying for our research to see that indeed that's where the accumulation of sediments will be. So to conclude, basically in this research, we saw that within the Ludwig active upwelling cell, that we had a high amount of nutrients recorded in this area compared to further north of Ludwig, going all the way to Angola, which is similar to the higher amount of nutrients seen within the southern Benguela upwelling cell, the areas of Cape Town, as you go further in South Atlantic. And because of that, we realize that and recognize that this has to happen because this is possible because of the upwelling cell, but also because it translates that the northern Benguela upwelling cell, which is further from the town of Lüderitz, it's where most organic carbon detritus are deposited, which then projects that growing kelp farms, like in the areas of Lüderitz, most of these carbon-rich kelp detritus are then deposited within the continental shelf in the depot center. So this then gave us an idea of basically the next steps to do is basically to do an isotopic signature of the sediment that is found in those depot center areas, as well as basically to look at other studies that are equally important to complement and also conclude this research. So one of them was basically to look at net primary production, which we have a student looking into that using satellite, where they use basically Landsat as well as Copernicus data services to see the chlorophyll concentration as well as the dissolved organic carbon. We're also looking into particulate organic carbon, where we collect sediments annually and then run different isotopic analysis to identify and also mark the different type of organic compounds found there. So just in a nutshell, this is what our research was all about. I want to extend an appreciation to the Copernicus Marine Services, the team that have given us an invitation to share these studies, but there are also equally important people that played a role with this research. The University of Namibia being one, the governments of Namibia, the University of Cambridge, where we collaborated, as well as Sustainable Ocean Alliance, and many other people that played a big role. So with this, my presentation comes to an end. Thank you so much, everyone. I appreciate that.
Thank you very much, Protasius, for your nice presentation. It was really interesting. It was nice to see. And we have a few questions for you. Oops. Go to the Q&A. So the first question being, what are the various anthropological factors contributing to the rise in CO2 levels, and what tools can be used to measure it accurately?
All right. Thank you. That's a very interesting question. There are a lot of anthropogenic activities, mainly, especially within the marine sector. There is a demand within the blue economy to work on different activities, including mining, including port activities, as well as different communities that depending on the ocean within those areas as well. And then when you mention tools, I think the main tools are, I love to visualize the measurement is starting from this atmosphere, where you basically have PCO2 sensors now that can measure carbon dioxide within the atmosphere. Then you have also within the water column, as well as looking into dissolved organic carbon that can quantify the amount of carbon that has been dissolved over time. Yeah.
Thanks a lot for the explanation. We will go to the next question. How do you explain the highest CO2 concentration in Walvis Bay?
All right, thanks. That's a good question, because Walvis Bay, one of the reasons why there's highest amount of carbon dioxide, research showed that this is where there is the carbon source, as I mentioned, depot center, as particles move and organic rich sediment are also moving. Within the Namibian area, there's the continental shelf of the Namibia. It narrows as you go further north. So it's not only Walvis Bay, but as you further go north, you also find areas where there's high amount of CO2. So there's more deposition happening there than in the south.
Okay, thanks a lot. It's clearer now. Next question. From this one, from Liberia, does the kelp forest have a potential for being a good marine pollution sink?
Okay, thank you, Alpheus, for the question. So kelp is an ecosystem engineer. So basically, you need kelp forest to be able to have healthy oceans. Number one is because they play a role of filtering the water quality, but also within the kelp forest, there are marine organisms that are hosted there as habitat that plays a role with to basically balance the ecosystem. You have organisms that basically play a role in filtering the ocean water as well. So it's not a good marine pollution. Yeah, actually, you're right when you say pollution sink, but because the kelp forest plays that role of basically filtering the amount of pollution that is in there. Yeah. I don't know if I've answered it correct, the Alpheus.
Maybe it was also like CO2 pollution, CO2 sink, something like that, I guess, like forest.
Yeah, no, I think when it comes to that, I like to explain that the kelp, similar to how we have the terrestrial plant, it takes carbon dioxide in the process of photosynthesis basically to make its own food. So the kelp plays that role as well. So it is also taking carbon that is stored within its blades and stems and stipes, and this carbon-rich kelp, then it has a potential of keeping it, but also as it drifts and cut off, it goes to these depot centers that basically goes to the seafloor that doesn't escape back. So that's the notion of how carbon is captured in the kelp forest.
Thanks a lot for the explanation. So this question I can answer. Can that presentation be shared so that we can take a deeper look for us who are interested? So yeah, all of the PDF presentations will be made available on the website during the afternoon, along with the replay of today. And then after both days, you will have obviously all of the presentation and both of the recordings. So no worries about that. Okay. This question, since you share the cost with SADEC, are you doing this research together?
I'm not familiar with the SADEC, but I know SADC.
I think, isn't it like the Southern African Development Community? I looked into it, but I'm not sure.
Yeah. So if it's SADC without the E, I think I can answer that. So with Kelp Blue has another entity, which is a non-profit organization called the Kelp Forest Foundation. I think you can look it up. So the Kelp Forest Foundation plays a role of linking this basically scientific knowledge with different hubs and different institutions. So the KFF, which is Kelp Forest Foundation, then partners with university like Cape Town in South Africa. We also partnering with local universities in Namibia, and it's open for different also different scholars and in institution that wants to get involved in what we do. Yeah.
Thanks a lot. How can remote sensing technologies be leveraged to identify suitable locations for kelp farming along the African coastline, and what data sets are most useful? General question.
Yeah, I think it's a great question. Remote sensing, I think, is a picture of the future when it comes to basically also not only looking for the location of the kelp forest to say, but also to see the health of the kelp forest. We are involved with different remote sensing companies that are offering to basically help us quantify the work that we do. If you know of some also, you can always reach out to us and see how we can leverage from that.
Thanks a lot for the explanation. So we'll continue the question. Have you looked for heavy metal concentration in the sediment?
Yes, we have looked into that. I just didn't cover it in the study, but yeah, we have information on that.
Okay, thanks a lot. And yeah, the link to your paper was published in the chat, so people can have a look for more detail if they want. Okay. Okay. So you said you took collection in Namibia near to the Angola region. So did you work with an Angolan researcher in your crew?
So we didn't reach Angola itself, but we're close to Angola in the Kunene area, which is still within the Namibian border. So we didn't have any Angolan researcher in our cruise vessel, but we had local other African scientists that joined.
Okay, thanks. So can continue. What are the conditions for the growth of the kelp salinity and temperature, and what is the daily production of oxygen?
So with salinity, I think it's a standard one within the southern Atlantic Ocean, which is around 34, 35 practical salinity unit. Temperature, the kelp, specific kelp we grow thrives between 9 to at least 14 degrees Celsius. When it comes to daily production of oxygen, I can't really diverge and give you much results for now on that, but feel free to reach out. I can explain more in detail.
Thanks for this explanation. So time for a few more questions. What type of machine learning methods were deployed to develop your water quality model?
So the water quality model, we still have an in-house model that we're working on, but part of the research, we collaborated with the University of Cambridge, where a professor in Cambridge basically took the institute data that we collected and then developed a biochemical model as well. We have, there's a link, in fact, perhaps I'll share this later, of a paper that was out because of that.
Okay, thanks. Yeah, don't hesitate to send the link. We will provide it in the post-event report also. So we have time for 2 more questions. How long do you think it will take for the kelp farming to significantly mitigate the effects of the CO2 increase?
When it comes to science, it's interesting to put a number. But for now, let me maybe talk on the aspect of what steps have we done. So we have created a baseline. So we continue to track the changes. And through the changes, we are also then developing that. There is already effect seen. So we have our in-house quantified the amount of carbon that has been sequestered. And then we continue to track that as time goes by.
Thanks a lot. Thanks a lot. And so we will go to the last question. What is the impact of the ocean currents and upwelling systems on the CO2 concentration?
On the CO2 concentration, I think it's still being studied, but I can mention on other aspect, other biogeochemical aspect, especially when it comes to nutrients. Because of the upwelling system, most of the nutrient-rich waters that are at the seafloor, they are then basically brought back to the surface, making the distribution of nutrients equally rich within the water column, especially during the upwelling season, the peak upwelling seasons.
Thanks a lot. So thanks a lot. So it was the last question. Thanks again for your nice presentation and joining us today. I hope people enjoy it. And yeah, so we will go to the next use cases then. So hi Valentina, welcome. And whenever the floor is yours to start your presentation. And you can stop the timer on your screen, don't worry. We take care of that.
Okay. Hello, everyone. Let me introduce myself. My name is Valentina Santarsiero, and I am a technical assistant in Blue Horizon team at Planetech Italia. My job consists in processing and interpreting satellite data, provide different information to develop an innovative Earth observation-based solutions for water quality monitoring, marine ecosystem analysis, and coastal monitoring. Today, I will show you the first result of a case study where data from Copernicus Marine Service were used. The main focus of this project were to try to identify and map the potential aquaculture sites, monitoring existing aquaculture sites and farms, and in the end, carry out a territorial and socioeconomic analysis mixing with the satellite data of the analyzed areas. The area of interest for this project were the south area of Bangladesh in the southwest division called Khulna division, and in the lake region of Kenya. So the first approach that we used in this type of analysis concerned to apply different type of data and algorithm to evaluate the water quality of the area. For example, the prefecture and division of Khulna in Bangladesh is very complicated to analyze, and in fact we divided this area in two parts. The first one in the box red, representing the inland area characterized by the presence of the very big river and a lot of farm of aquaculture of aquaculture. In Bangladesh, the main aquaculture sites are represented by ponds. And the second subzone in black box is represented by a sea area characterized by estuaries of the big river and the ocean. The water quality analysis, in the water quality analysis, we try to assess different parameters such as turbidity, water transparency, and chlorophyll A concentration. And we use different data and different algorithms to assess the parameter. Today, I will show you the first and the previous results about the concentration of chlorophyll A derived by the data presence of Copernicus Marine Services and derived also by the application of different type algorithms using the sensor of satellite Sentinel-2. So the concentration of chlorophyll A represents a good indicator of phytoplankton biomass, which is a primary source of nutrition for marine fish and mussels. And knowing the CLA concentrations is help us to understand the availability of resources for food for fish. And the data, for example, present in the Copernicus Marine are very useful for us to analyzing the concentration of chlorophyll in this case and monitoring the primary productivity of the seas, and offering us a very important opportunity to optimize the aquaculture as a resource and also as management. Now I will show you the first result of the seawater area. And in the first case, we use the data presence of Copernicus Marine Service. And in the second picture with the blue palette, we can observe the mean of chlorophyll. So I'm sorry, the period that we take the analysis goes to from 2023 and 2024. And in this map, we can see the mean of the data of Copernicus Marine Services of the CLA concentration during the entire period. As you can see, the concentration of chlorophyll vary between the area of the sea and the area of the estuaries and river. We use BAF data, monthly and daily data. In fact, in the next images, we can also subdivide the sea area in other sun zones. For this reason, it's more easy for us try to understand the trend of concentration of daily variation of chlorophyll. In fact, daily and monthly data allow us to analyze temporal and seasonal variables that influence the presence of phytoplankton, like temperature, currents, and nutrients. CLA concentrations is concentrated in the surf water column and are very easy to observe by satellite. And in this case, the daily data allow us monitoring of rapid variation in concentration of chlorophyll and try to identify, for example, a phenomenon like alga bloom or eutrophication of the sea following, for example, an increase of nutrients. And the result of this phenomena is the oxygen deficiency of the sea and is harmful from farmed fish. In this map, as you can see, the monthly concentration A map during 2023, and also in this other slide are represented the monthly chlorophyll concentration maps for 2024. We stopped this analysis in September of 2024 because the period in these areas ending in this data. So at monthly level, the concentration of chlorophyll vary seasonally and depending of the availability of lights, for example, and nutrients. And analyzing historical series for monthly data is useful and help us to identify more stable and suitable areas for aquaculture plants and avoid the areas with extreme fluctuations. In this slide is represented the results of the analysis of water quality of chlorophyll A using Sentinel-2 data. And in the second picture, as you can see, the two areas with represented the mean of chlorophyll A concentration assessing using Sentinel-2 satellite. And as you can see, in the inland area are present a lot of small lake and ponds. After that, we try to connect the satellite data results with the network data and socioeconomic data. We try to mixing these results in landside analysis, and the third picture represents an example of this type of analysis analysis and representing the accessibility network map. The accessibility between the ponds, so the farm, the fish farm, and the first fish market. So it's very important when we manage and assess the aquaculture sites. It's very important to connect the water quality analysis with the land side and socioeconomic data. The same approach is used also in Kenya. We use we choose the Lake Victoria area, and also in this case we subdivided the area of the Lake Victoria in different time zones. Because for us it's more useful to understand the phenomenon of concentration, for example, of turbidity or on chlorophyll and other parameters. And in the other picture, I will show you the daily concentration, an example of daily concentration of chlorophyll derived by the Copernicus Marine Service, and the monthly concentration of chlorophyll A. In the other slide, as like for Bangladesh, are represented the map of monthly chlorophyll concentration for 2023 and for 2024. For Kenya, we try to apply another type of approach for only at this moment only for Sentinel-2 data. We try to assess a seasonal statistics of the concentration of the parameter that I show you previously, and we try to study the summer season, the summer concentration of chlorophyll and the chlorophyll concentration in winter. As you can see, there are a very bit difference from summer to winter. And in this slide are represented by the data of the mean summer concentration of chlorophyll in 2023 and the winter mean chlorophyll concentration at 2024. The range of chlorophyll A concentration for aquaculture depends of the environment and the species the species farmed. In general, high concentration value indicate a risk of eutrophication, while low values indicate a limit to the productivity. For example, when we study in the Bangladesh area the inland water and we analyze the chlorophyll concentration in the river, the optimal range varies from 1 to 10 micrograms per liter. But the value of the concentration range in the river vary because in the river that are present a strong currents, the trends can be the trends of concentration of chlorophyll is lower. For the coastal and area and sea area, the value the range varies from 0.1 to 5, and when you find the value higher than 10 micrograms per liter, is clearly the presence of alga bloom. In the end, in the lake equatorial, like Lake Victoria, the range varies from 5 to 10. But it depends also the type of fish farmed. And in this case, from Kenya and Bafon, Bangladesh, the main species farmed is tilapia, and tilapia tolerated high chlorophyll concentration level. So, thank you very much.
Thanks a lot for your presentation, Valentina. So it was really nice to see that, and we have a few questions for you. So the first one being, which is more accurate for extraction of chlorophyll A concentration, Sentinel-2 or Sentinel-3, and why?
It depends of the area that we analyze the chlorophyll concentration. Sentinel-3 is more suitable from the area of big lakes or coastal area, but at the pixel resolution are 300 meters. While Sentinel-2 data is more useful for inland area, like near the river, or to analyze the farmed with a lot of number of ponds, because the pixel resolution are about 10 meters. But Sentinel-2 is not easy from to have every 5 days the data of Sentinel-2 because there are no other problems. So it depends of the area where to want to apply the analysis.
Okay, thanks a lot for the explanation. This question being in the same type of question, what is the maximum depth of chlorophyll and turbidity data, and what is the type of acquisition?
So I don't remember exactly the depth of chlorophyll concentrations. Maybe I assume that the question is related to satellite data. Because the maximum depth of chlorophyll data and acquisition depends if we analyze the satellite data or in situ data. I don't remember from satellite data, but maybe in the 2 or 5 meters under the surface. And the type of acquisition in situ data, there are different type of acquisitions. Maybe it's we can take a very small quantity of water and bring us in a laboratory, or there are an instrument that measure the concentration in situ.
Okay, thanks a lot for the explanation. Okay, so we have this question. So chlorophyll A values at 10 microgram per liter in the area. Have analysis of phytoplankton been conducted to identify potential toxin-producing species?
No, we don't have been this type of analysis.
Thanks. So now we have kind of the same question. What software do you use to measure chlorophyll concentration and analyze water quality results?
From the chlorophyll A concentration derived by Sentinel-3, we use the Copernicus marine data service, And from Sentinel-2, we use the software like Snap.
Thanks a lot. Okay. Also, this question being kind of the same, but this one about what software did you use to analyze Sentinel-2 data to get the 10-meter resolution? And did you download raw images? On what kind of data did you download?
So I use the Snap data, but no, for the download raw images, I use APK, and I'm downloading all from satellite analysis only the Sentinel-2 data, and I applied the algorithm present of the software, the C2STC algorithm.
Okay, thanks a lot for the explanation. This one about which wavelengths of light the chlorophyll absorbed the best?
From Sentinel-2, the before band, red, are near infrared.
Okay, thanks a lot. One question. Is there a need to undertake projection so that to identify the sustainable sites?
So when we try to identify the suitable sites, we use different approach. So we ask and talk more with our partner that indicates what is the area that they prefer to connect, to prefer collocate the new site, the new farm. After that, we mix our data with the water quality analysis with other type of data. For example, we use the land use map, the socioeconomic map derived by a lot of socioeconomic analysis, and we also use the data related to and we check when it's impossible to find the map. We check from both of the area what are the protected areas, because in the protected area it's impossible to apply aquaculture.
Yeah, thanks a lot for the explanation. So we have time for 2 more questions, I think. According to your studies, how is the concentration of chlorophyll in the water column?
It depends of the area that we take our analysis. For example, in the Kenya, in the Lake Victoria, the concentration of chlorophyll is vary from 5 to 20. The main value in 2023 is 15 micrograms per liter. And for the aquaculture, the aquaculture is good because in the Kenya, the main aquaculture farm is related to farm the tilapia, and the form of aquaculture is in a cage, so in the water.
Okay, thanks a lot. And so the last question for today, Sentinel-3 can provide the chlorophyll A data very well. Why did you choose to go with the Sentinel-2?
We use Sentinel-2 because with Sentinel-3 it's impossible to study and provide and understand and calculate the chlorophyll A concentration in the area near the coast, near the river.
Okay, thanks a lot. So we will have to stop there for the question, but as usual for the answer question, I will put them on the slide. Thanks again, Valentina, for your nice presentation.
Thank you very much.
And
have a nice day.
Have a nice day, you too. And yeah, we will go to the last use cases of the day. So I will welcome the last speaker. So Karim from thanks. And yeah, welcome Karim. And whenever you want,
you. Yeah,
you can start.
I think, okay. Do you seeing my mouse moving?
Yeah, it's okay.
Okay. But the screen doesn't work. Okay, yeah, it's nice. Oops, sorry. What happened there? All right. Thank you for having me. Abdul Karim Thiam, a PhD candidate at Lagos Laboratory. It is a laboratory aims for geophysical and spatial oceanography. So my topic of work is about mesoscale dynamics and its interaction with coastal upwelling in the northern Gulf of Guinea. So the Gulf of Guinea is a region in the eastern part of the tropical Atlantic Ocean. So it is characterized by a high coastal population density with activity like fishing and farming. Also, meanwhile, the regional climate is tightly condition of the ocean. So by the condition of the sun, we have a seasonal setting of upwelling, the equatorial one that you can see here, and the coastal one. So the appearance of these two patterns lead to a temperature gradient, a sea-surface temperature gradient that enhance the so-called so that bring water vapor in the continent. And then this wind will meet the northeasterly wind that I do not represent here. And when they meet, they trigger some convective activity that is very important to trigger precipitation. And the maximum precipitation is located alongside this intertropical convergence zone. That is very important for the activities that I mentioned earlier, like farming and fishing also. So knowing the condition of the ocean is very important for this region and process leading to the setting of this pattern. Among these processes, we can have a mesoscale processes. And when I talk about mesoscale, I'm referring to equatorial and coastal tropic wave, and also process from mesoscale eddies. And we are going to focus on this last one. So eddies are quasi-circular structure that has the ability to trap water masses and travel to a long distance from away from the bone. So they have a spatial scale ranging from 10 to 100 kilometers and a temporal scale from day to a few months. So here, my purpose is to feature or to characterize the mesoscale eddies and try to find out how they can interact with the northern Gulf of Guinea upwelling system that you can see here. So to do that, I'm dealing with Eulerian simulation from NEMO models. It is an eddy resolving configuration, so that I use in the Gulf of Guinea with a resolution of 3 kilometers and 50 vertical levels. I use lateral boundary forcing from an initial condition from Mercator analysis Gloris. And for the continental freshwater runoff is from East Basset Trip and IBAM Institute data from Congo River. And the vertical mixing was computed using a generic length scale formulations. And I have run the model for 11 years. From 2007 to 2017 with a 2 year of spin-up and in a daily output. I have also deal with observation data like altimetry from SEMEMS and other satellite in situ and satellite data, blended in situ and satellite data like OESST, SST from MU, MODIS, and so on. I have also used Pirasha data and data from thermosalinograph that was equipped in a commercial ship. I have also I have also performed the edX section using the algorithm designed by Chignon and all that I apply on both the CMMs and Nemo absolute dynamic topography. So with this algorithm, the vortex or the eddies is identified by identifying first the local extremum, like a minimum or maximum absolute dynamic topography. And the edge is defined like the outmost close contour that contain these extremum local. And in addition of that, we can also record the radius of the eddies, the amplitude, the lifetime, and their trajectory also. And I have also perform a Lagrangian simulation to track water masses trapped within the eddy to know where they come from and what will be their fate. So I validate my model using against the observation data. So here it is. Now it is disturbed. Now it's not good here. All this column is for the model, and the other one is for observation. So SMAP should be here. I don't know. It is disturbing my presentation, but anyway, observation is here. Here is OUSST that I compare with the models. And I have also do validation with the C-surface salinity by comparing the track of pirata campaign and a commercial ship. And the absolute dynamic topography from models that I compare to the one for CMMs. And also the current from models that I compare with current from drift. This should be here. So we can see the upwelling well represented by the model where we compare it with OESST data. And also the Guinean current, like you can see here, is well represented from the model. So here I summarize all the all the comparison or validation that I made with other observation data that you can see here in terms of correlation, standard deviation, and root mean square error. So in a word, one bias ranging from 0.03 degrees Celsius to 0.63 can be found, and have a Frisch base from my model ranging from minus 0.52 to minus 0.15, and a weak absolute dynamic bias, it's nearly zero. So it makes us confident that our model is representing the main feature in this region, so we can use it for analyzing the mesoscale dynamics. So move on. Here I perform the extraction by comparing the extraction from Nemo and the one from altimetry from CMMs. So I represent here the eddy center, donc dot for cyclonic eddy and star for anticyclonic eddy. The first day they are detected. So the shaded pixel is the one that hosts at least eddy for a month. So it's on when we compare it, we find a very good consistency between the two products, Nemo and CMM saturation. And the associated radius of all this eddy, we can see it. We have a very nice comparable values that you can find also. And for amplitude also, it's very similar compared to the altimeter. But we find more cyclonic eddies for Nemo, especially near the coast compared to altimeter. And also for the anticyclonic eddy, we have a comparable values. We have a 35 for Nemo and 34 for altimetric. So it's very nice, and it represents well the different patterns that we expect. So what I use, so to see the interannual variability and the seasonal of the detected eddies, I perform this by separating the detected eddy in different boxes. Box 1 and 2 and box 3 at the vicinity of the Niger River. So we can see at every year, at least we found one cyclonic eddy when we take the box 1, we have 10 years of out 11 that we can see, the detected cyclone, and the same one for box 2 and box 3. And when we analyze closely the seasonal variability, we find seasonal modulations. We find a peak of cyclonic eddy during the minor upwelling season and a max during the major upwelling season. You can see it for the box 2 also, but it is less evidence with the box 3. So to try to explain the mechanism behind the generation of the eddies in terms of baroclinic to try to explain it. So the question is based on the gradient of the potential vorticity. So for an eddy to be barotrophically generated, the value of C should be changing C. The sign of the C value of the crystal should change, and we should have also weak valence for eddy to be barotropically generated. So what we find here, I shade the parameter C here, and I add the eddies detected at the first time we see them. So here for the July, August, September, and for the bottom one we have the July situations, and I add this eddy center and the contour here that you can see, cyclonic for the blue edge and anticyclonic for the black edge. So I summarize it here by putting different class ranging from -25 to 25, and I add the number of eddy belonging to each classes. So we can see a very consistency between the two product altimetry from Siemens and Zinemo. So most of the cyclonic and anticyclonic eddies from the altimetry are barotropically generated, but there are differences when we compare from NEMO, particularly for the cyclonic eddies. There is a deviation from the low values here. So that means other process like baroclinic should be invoked for cyclonic eddies. So after that, I do a case study to try to see how eddies can interact with the coastal upwelling and modulate it. So here is a case study of July 2016, where I focus on the cyclonic eddies found here. And we can see this signature in salinity here and temperature that we will quantify later. And the associated signal of absolute dynamic topography is a minimum here that we can see. In terms of relative vorticity, it is a positive relative vorticity. And when we plot the cross-shore section here, we see that the core of the eddy is found around 20 meters here. So to know where the eddy, the water mass is trapped within the eddy come from, I perform a Lagrangian simulation. So I put more than 1,000 virtual particles here at the date the eddy was firstly detected. So I track back this particle to see where they come from. So before the eddies formed, they were at the east and the west side of the Cap 3 points, at a depth ranging from 15 to 30 meters, and the associated temperature is they was cold before warmed within the eddy, and salinity associated is they was very salty, and once in the eddy they are refreshed. So here I try to find the close relation between how the eddy displacement and the eddy center and upwelling threshold displacement, how they interact, how eddy can modulate the extension of the upwelling, here defined by the isotherm of 25 degrees that we can see here. So combining the two frames, we see that there is a close relation between the displacement of the eddy center and the upwelling threshold. They are correlated to coefficient of correlation of 0.64 and in a level of significance of 99%. So here I quantify this relation in terms of heat budget. So the temperature within the box depend on the term like advection, lateral diffusion, vertical diffusion, and the interaction of the ocean atmosphere that you can see here. But what I do, I isolate the contribution of the eddy from the mean situation or the mean state by doing a filtering by using a cut frequency of 1/30 days, because the eddy lasts at least a month. That's why I use these frequencies. So, and at this cutting of frequencies, the dominant term is the advection term. That's why I only shade it here, that we can see. So we distinguish two phases. The first phase is since the eddy is born to to 26th of July, we have a cooling of the temperature, and in a second phase where the eddy warms the upwelling cells. So in terms of advection, how I explain it, so it is highly the eddy cold temperature, so that we can see here by the dash line. It dominates by eddy, and at the second, it's for the warm that we see here. And when we take at different boundary of the box, we see that eddies cool the upwelling by the eastern side that you can see here, and the west side, and they warm it from the east side mainly. And for the south, we have a cooling at the first phase of cooling phase, and at the second phase, they warm it by the south far. Just to try to see in a 2D situation, we have the Ghanaian current that flowing here and bring warm water in the upwelling cell that you can see here. Meanwhile, the eddy is cooling it, like here, that we can see in blue. And when eddies enter in the box, they are evacuated by the Ghanaian current, like we can see here in this color. Meanwhile, the eddy is warming the upwelling by advecting inflow warm water in the upwelling cells. And for the south boundary, we see that the detachment of the Ghanaian current here called the south boundary that we can see here. And when he flow back to the coast, it warm it again. And when we take the contribution of the eddies, we see globally we have similar pattern, but globally he is a cooling phase. So in conclusion, cyclonic eddy preferentially form in the upwelling east. In the upwelling area eastward of Cap 3 Point and Cap Palmas, and cyclonic eddy are mostly found offshore along the Guinean current latitude and east of 3 degrees at the vicinity of the Niger River plume. 38 cyclonic and 35 anticyclonic eddy trajectory were detected over the July, August, September period from the NEMO, and 22 cyclonic and 35 anticyclonic eddy trajectory from the same altimetry. Our NEMO simulation and altimetry from CMMs agree that cyclonic eddy generation could be mainly explained by barotropic instability, whereas baroclinic ones should be involved for cyclonic eddies as found in NEMO. In our case study, eddy influence coastal upwelling at intraseasonal scale in two ways. The first one is upwelling enhancement and an offshore advection of cold water in the first phase from July 17 to July 26. And at the second ways, it prevents from upwelling establishment in a second and longer phase by advecting warm inflow water through south and mainly eastern boundary from July 27 to August 13th. So one thing I will add before, after is I'm open to work for any related topic. So feel free to reach me out via my email address. So thank you for your listening.
Thank you very much, Karim, for your nice presentations. Obviously, we'll put the PDF available for everyone to have a look at and contact you if they want. So for now, we don't have any question. Can wait a few seconds to see, but yeah, you have greetings and kudos from people in the chat also, so well done. Just looking if I have question coming. No, okay, so I don't think we have any question coming for your presentation. Oh, okay, so no, we have one. We have one, sorry. Okay, yeah, so I'm missing the first part of the question. So, well, the question are in the wrong order, but so Indian Ocean, especially in South Africa, are experiencing a lot of aftermath of cyclones and hurricanes, such as floods, which destroys infrastructures and affect the ocean ecosystem. How can this research help?
Which destroy infection and affect the ocean ecosystem. How? I don't understand what he really mean. Which destroy infection and affect the ocean ecosystem.
I think it's like how your research can help prevent like the destruction of infrastructure.
Infrastructure, yeah, but here I deal with ocean eddies. According to my extraction that I made, maybe the eddy doesn't hit the coast. They expand offshore. It's not atmospheric cyclonic eddies that can travel all the continent. It is located in the, what I can say, in the middle of the ocean. But yes, for ecosystem, maybe it can enhance maybe for the chlorophyll bloom because eddies can like for cyclone can boost the generation of chlorophyll by advecting rich nutrient water upward. Yeah.
Thanks a lot. So we have next question. What was the essence of using the Lagrangian principle in your study?
Yeah, to track particles. So, do you know when we want to flow the eddy, we need to track the particles to know where they come from and what will be their fate. From that, we can see the different property associated to the eddy. And also, when we are doing a potential vorticity analysis, it is preferential to use a Lagrangian simulation since the potential vorticity is conserved for each particle. So you can see how the eddy was generated. It's very essential to use Lagrangian simulation.
Thanks a lot. And one more question. Are the eddies strong or powerful in West Africa, especially in the...
Yeah, they are also strong because we can see eddies, the range of the eddies range more than 100 kilometers, and they travel a long distance, and so it's very powerful also in West Africa. Yeah, but for what I can say, it's more like when we go at the north side that it is very frequent there compared to the Gulf of Guinea.
Thanks a lot. And I think we have time for one more question. Is coastal erosion caused by eddy in coastal Africa?
No, I don't think so. I don't know, so, because yes, if it is close to the coast, but it's not tightly related. Yeah, for sure.
So, we have few more questions. We will have time to do one or two more. What software did you use to refine your results?
What she mean from the what software do you use to
did you use Python or MATLAB?
Yeah. Okay, I use Python. I deal with Python, but for the eddy extraction, the code it is implemented on MATLAB.
Okay,
but
good to know.
Most of the result is made by Python, the plotting, yeah, and the analysis also. It's just the eddy extraction that I use the Python script, MATLAB script.
Okay, thanks a lot. And yeah, so we will do two more questions and then we will have to stop. Was there any sea surface temperature contribution to the study on eddies?
Was there any sea surface temperature contribution to the study on eddy? I don't know. I don't understand also what he means from there.
Yeah, I think did you study the SST when you studied?
Yeah, I show it on my presentation, so maybe it was not clear from at this point. I use sea surface temperature to see to look at the signal associated to the eddies, and also a heat budget in the within the mixed layer to see how temperature trends can be triggered by the eddy setting.
Okay, thanks for the explanation. And one last question. What are the key impacts of mesoscale processes in the northern Gulf of Guinea on marine life and coastal communities' activities across season? So it's general.
Yeah. For the impact, mesoscale eddies can enhance the upwelling, like I show by offshore advection of the upwelling. So where we are water masses that is offshore advected, they should be replaced by, according to the equation of the conservation of masses, by upward water. So you enhance your upwelling from there, and the rich nutrient water upward at the surface is very rich in nutrients, so it can help for the phytoplankton and zooplankton growing, and it's very favoring the fishing, as you can see. And the last one is coastal community activity. Yes, like fishing, and also the climate. Because when we have upwelling, like I show, it enhances the wind towards the coast, and these winds are very rich in water vapors, and when they meet with the northeasterly wind, they can trigger convective activities that favor cloud and so precipitation, and it's very useful for the agriculture and farming or farming. Yeah.
Okay, thanks a lot for the explanation. That was the last question for you today. And yes, thanks again for your presentation.
Thank you for having me, everyone.
And yes, so we are reaching the end of today's session. So I hope you enjoyed this morning. And thanks again to all of our speakers for their great presentation and their Q&A session. So for the unanswered question, we will provide the answer later in a post-event report, and we will make it available during the week. And yeah, so as you know, the practical session will be the day after tomorrow. So if you haven't had time yet, I invite you to check the full tutorials to get ready for it. So they are available in full on the website, and you can find the Jupyter, QGIS, and Air Studio on the website, all of the tutorials using the Copernicus marine data. So you can download the tutorial and start your practice if you want. And yeah, finally, I also just want to remind you that there is a section on the website, so next to the Q&A, reserved to the polls, and we would really like to have your feedback on today and what we could provide in the future. So if you can take 2 minutes of your time, that would be really helpful. And well, yeah, have a nice day, and see you in today's Wednesday at 10 a.m. CET. Have a nice day. Goodbye.